All right, guys, I'm going to finish up those last problems, the hands on the clock problem. And I know some of you don't know how to tell time on a regular clock or on a analog watch that just has hands and not digital. But that's what these problems are dealing with, and they do appear on the ACT and SAT test. So it is important that we learn how to use them. So we're on page 510. It says the hands on the clock point in the same direction. So it doesn't really matter what time it is as long as I do something where the hands are in the same direction. So the one I'm thinking about is just like straight up noon, 12 o'clock. In how many minutes will they point in opposite directions? Okay, well, in the first place, we've got a shorthand and we've got a longhand in a clock. Okay, so this is the shorthand and this is the longhand, just like what it sounds. The shorthand is the one that indicates the hour. So the rate of the shorthand is, it's going to move how many spaces in an hour. Remember, on a clock, if this is 12 and this is 1, there's 1, 2, 3, 4, 5 in between, right? So this would be, it would cover 5 spaces in 60 minutes, or it is 1 over 12. The longhand goes around 60 spaces in 60 minutes, doesn't it? Okay, there's 60 minutes in an hour, so it goes around 60 spaces in 60 minutes. So the rate of the longhand is 1. Okay, you're going to need to memorize that. Okay, memorize the rate of the shorthand is 1/12, rate of the longhand is 1. Then the other thing is the time of the shorthand is always going to be equal to the time of the longhand. We can't take the hands off of the clock and hold them and say, wait a minute, you're going too fast, or wait, I want to wait for this guy to catch up. No, we don't do that. They're moving the same amount of time. So TS is always equal to TL. So what we have is, we have a distance for the shorthand. How far does the shorthand move? And we're going to arbitrarily call it S. And then for our other equation, we'll always be comparing it to this. Okay? So in this case, it says the hands are pointing the same direction, right here. How long will it take for them to be pointing opposite directions? Well, if this little one doesn't move, this one's going to have to come around here how many spaces in order for it to be in opposite direction? It's 30 minutes, right? So we're going to say that the shorthand moves S, because what happens is this little shorthand is going to move out here a little bit, right? So then the longhand, in order to be in opposite directions, is going to have to be that S plus the 30 minutes, so they'll actually be opposite each other. So the longhand distance is S plus 30. And this right here is going to be different depending on the problem. This one will be the same equation, this will be the same equation, this will be the same equation. This is the one that's going to change right here. All right, so now what I'm going to do is I'm going to solve this for S. So this would say S equals RLTL minus 30, right? Okay, well, that's S, but this is also S. So if they're both solved for S, what can we do with them? We can set them equal to each other. So RLTL minus 30 is equal to RSTS. And now we're just going to substitute what we've got. RL is 1 times TL. RS is 1/12. And because these guys are equal, I'll just change this one to TL, so we just have one variable.
So now if I subtract this from both sides, I'll get negative 30 is equal to negative 11/12 TL, because the negative 1 plus 1/12. And then we multiply by negative 12 over 11 on both sides. So it's obviously going to be positive. If it's not, we made a big mistake somewhere. There's no negative time. So 12 times 30 would be 360 over 11. And that's the answer. Doesn't have to be a pretty answer. That's it. All right, so remember, you got to know this one, got to know this one, you got to know this one, and remember that TS is equal to TL. So let's try one more. This one says, it is 3 o'clock. Okay, so that's what 3 o'clock looks like. In how many minutes will the two hands of the clock point in the same direction? Okay, now remember, RSTS is equal to S. That's how much this little guy is going to move. If he didn't move, this one would have to go how many units to catch up to it? 15, right? So it's going to be however far the S moves plus 15 more. So there are those equations. Remember, TL equals TS. RS is 1/12. RL is 1. Solve this for S. Now there's an S and there's an S, so set them equal to each other. And plug in what we've got. So RS is 1, TS equals 1/12. RL is 1. We'll change that to a TS. Now if I subtract 1 TS from both sides, I get minus 11/12 TS equals minus 15. And finally multiply by the reciprocal. So TS, let's see, 15 times 10 is 150. And then 24. Oh, I can't do that in my head. $180. So 180 over 11. And it's fine just to leave it like that. If you really wanted to see how far it was, you could divide that out, and it would come out to be 16 4/11. So that shows you on the clock for them to be pointing in the same direction. From 3 o'clock, it would actually take 16 4/11 minutes for them to point in the same direction, where you might just automatically think it would just be 15, but it's not. All right, so that's the second video for that lesson. Thank you very much.